Hey there, welcome back to the FTC Student's Guide to Autodesk Inventor. I'm Nick from Hazmat Biohazards, and in this episode, we're going to talk constraints and assemblies, some of the most important tools for FTC. Since last time, if you're following along, you should have downloaded the 10650 FTC Public CAD Library off our GrabCAD and moved the files to your Inventor project folder, in which case you're all set to use all of the 400 plus parts in your CAD assemblies. If you didn't do that, you can find a link in the description where you can download those resources before we work with them this episode. Of course, if you already have some common CAD parts in a library, you can just use that too. Anyway, now that we have all sorts of files to work with, let's make a new assembly in Inventor. So you should recognize this screen from last episode. You have your sidebar over here on the left where all your parts are going to go. Obviously, we haven't put anything in here yet, so it's all empty. On the top tab, make sure you're on the Assemble tab, right? And let's press the place button. So this opens up a file browser inside your project folder. If you don't see a part that you're looking for in this folder, that means it's in the wrong place. So if you don't see the CAD library, for example, that you should have put in here, that means you put it in the wrong file directory and move it into this folder right here. So let's go to Tetrix and look at the channel files. So here you can see that all of the files are .step files. And so .step is sort of like a universal CAD format. .step files are importable by tons of CAD programs. If you see something like .ipt or .iam, those are file formats exclusive to Inventor. So .ipt is an Inventor part and .iam is an Inventor assembly. As you import a step file, we'll see in a second that it actually converts a step file to an IPT, which is then what Inventor works with directly. So anyway, let's grab a 160 millimeter channel, click on the file, press open. Now, if you're trying to open an IPT file or an Inventor part file, you're not going to see this screen when you import it. But if you're opening a step file, this big, scary prompt window will ask you how you want to import the file. So the default settings for step files are fine. Go ahead, ignore it, just press OK. All goes well, you're going to see the part on your cursor, and it will look really transparent-y. So if you click, it'll place the part. So if you want to place multiples of this part, you can just keep clicking, and you can keep placing more of that same part. So place a Tetrix channel or two, and tap the escape key to stop placing. Now before we go any further, it's time to learn how to move the camera around a part or assembly so you can actually look at what you're doing. If you click in your middle mouse scroll wheel, that's M3, and drag your mouse around, you can pan the camera around. Your scroll wheel will zoom you in and out. Just be careful, because sometimes if you zoom in or out like really far, your program is going to lag, and it can sometimes even cause it to crash just because it has to render the level of detail as you zoom in that much. If you hold down the shift key and then you press and hold the middle mouse button, moving your mouse is going to cause your view to rotate. If you want to snap to a view, look at this little cube shape in the upper right hand corner of the viewer. Clicking on a face or an angle is going to move your camera to a specific view. So if you lose track of where you are in your workspace or you lose your assembly, just press the little home icon next to the view cube and it'll bring you back. When you practice a bit, you're going to learn how to fly through the camera viewing to work on all the parts you need to. You'll get better at it just subconsciously the more you work. So we've got this Tetrix beam in our assembly here, but let's say we want a few more of them to work with. So rather than going through the placement tool again, we can really quickly clone parts of an assembly by copy and pasting it. Again, just like Microsoft Words. And you'll find that quite a few keyboard shortcuts work in Inventor that are just like generic to Windows, So select the part, press Control-C, and then Control-V. Now you have a copy of the part. You can copy and paste a lot of different things in Inventor. Paste some more, so you've got 4 Tetrix channels total. If you take your mouse and click and hold on a channel, you can actually drag it around. So if a part is in your way, you can move it around by dragging it out of the way. Later on, this little dragging motion, you can make wheels sort of turn or other parts move depending on how they're constrained. So now, let's take a look at how we can put these parts together. So in real life, you might use screws and nuts to put things together, but in CAD, we do this through constraints. So what are constraints? Constraints are geometric rules that hold parts to each other. So depending on the type of constraint that you have and what surfaces of the part you select, you can put things together in lots of ways. The constraint tool can be found under the Assemble tab in your toolbar and can also be quickly accessed by pressing C on your keyboard. So to get started, we're using the most simple and versatile constraint in Inventor, the mate constraint. So let's constrain the face of one Tetrix channel with that of another. If you hover over the face of a part, it's going to have a white outline. You can select it by clicking on it. If you click on another face of another part, the constraint will be previewed in the viewer. You can see that by default, the mate constraint mates 2 faces together. If you press OK, the constraint is saved and applied, and the constraint box will close. If you press apply, however, the constraint box will be saved and applied, but the constraint menu will then reset and remain open for the next constraint. So this is helpful if you want to do a lot of constraints in a row. If you want to do another constraint, press apply. If you're done with constraints, just press OK. So we can see that no matter how you drag the part around, we can't really move these 2 beams in a way that the constraint is going to break. So no matter how we drag these 2 parts around, these two faces are still going to be on the same plane. The make constraint can constrain a lot more than just faces, however. It can also constrain axes, which are also really important. Anytime that you have a circular shape, like say the hole in a channel, or you have an axle, or anything really, there is an axis that passes through a center point. And we can constrain that axis with another to make an L shape with our touch channels. So press the constraint box and pick a hole that you want to constrain. Hovering over it, you might see this little green point. So this is actually not the axis, it's the center point of the hole. You never really want to constrain something to that green center point hole. So make sure you look for the dashed line. That's the axis, and that's what you want to select when you're making your axis constraint. If you move your cursor more into the wall of the hole and not on like the circle at the surface of the hole, you can really see the axis, which is this dotted line here. So click on that to select it. Now you can select the second axis you want to constrain. So let's do that. And notice how the axes and therefore the holes then are kind of lined up. So if you press OK and apply that constraint, now try clicking and dragging on one of the Tetrix channels, and you notice that it pivots because now there's another geometric rule. These two holes, these two axes of these holes have to be aligned, and so it can't break that. So if you're thinking about it like in real life, you can almost imagine that you've put a bolt in these holes that's holding them together. And if you want it to stop pivoting and be secure, then what you'd have to do is put a second bolt. If you put another constraint, constraining another set of these two axes together, we can now see the channels, when I press OK, are secured in an L shape. So this assembly, this little L shape thing, is made using one type of constraint, the make constraint, to constrain two sets of axes as well as the faces so we selected in the make constraint. These parts are completely constrained together, which means that they cannot move independently of another. So if you move one, the other one's going to move, translate with it. There's no more pivoting, there's no more rotating. They are exactly together. They are basically, you can almost think of them as one part now, because you have the two of them put together, combined into a bigger part, which is an assembly, by the way. So using these constraints, we can pretty easily take the other two channels that we have and form a complete square, which you could use as a really basic robot drive frame. By using this one make constraint tool to constrain additional axes and faces, you can really easily start to add in other parts as well. So say smaller channels, bearings, axles, wheels, gears, basically anything that you want to put onto your robot drive frame, you can constrain by the axes and faces using the make constraint. The more that you use constraints, the more familiar with them you're going to be and how you can use them to hold parts together. So, alright, but what if you make a mistake in connecting two parts? You need to go back and edit an old constraint that you've already made. So if we go to the handy sidebar and click on the drop down on a part, you can see all the constraints that are affecting that part in the assembly. If I hover over this make constraint, I can see what selected faces or axes are being constrained. So that's a really good way to identify your constraint. You can also name them, by the way, if you want to name a constraint. Sometimes when I'm working with a complicated arm or something like that, I'll make a constraint just temporarily to hold something in place, and I'll name it temporary constraint. So that way I know that when I want to move that arm again to test my design in CAD, then I can delete it. So that can be helpful for you as well. If I wanted to delete this constraint, I can right click on it and press delete or hit the delete key. So notice how this channel is only constrained by the axes, and so I can hover over it, move it around freely. Now let's look at some other types of constraints. Now I'm going to make a couple more channels to work with here. If I open the constraint tool and leave the constraint type on a make constraint, but this time under solution, select the box on the right, look what can happen when I constrain two faces together. Now these two faces are flush with each other, which is why we call this constraint a flush constraint, even though it's under the mate tool. Inventor is kind of confusing in that way. Other programs like SolidWorks aren't like that. This constraint can be very useful when you're assembling parts. So in this case, I'm using a flush constraint and a mate constraint to have two parts back to back, but they still slide along each other. You see when you move it, they're not completely constrained. In real life, you'd have to put a screw into two of these holes so the channels wouldn't slide. But let's look at doing it another way, using a flush constraint. If I press constrain and set the solution to give me a flush constraint and then select the end of the channels, you can see now the channels are completely constrained back to back. So constraining parts this way can be really useful when you're working with extrusion, because when you think about when you have extrusion, it doesn't have holes alongside of your constraint. So definitely you want to use the end faces and the sides of extrusion when you want to constrain it. Now, let's tell Inventor we want it to do something impossible. So both of these pieces are fully constrained. But what if I tell Inventor that I want this face to be flush with this face on the bottom? So it's impossible, right? If you wanted to move it in that way that they'd be flush, you'd have to break another constraint, which that can't happen, right? So the top two faces are constrained and these bottom two. So what happens if we press OK? The assembly cannot be solved. Chances are you're going to be running into this pop-up quite a bit, and that can be really frustrating. Sometimes things that seem like you should be able to constrain, Inventor will give you errors for trying to constrain. This can mean that really a small mistake in your assembly can cause you big problems. What I would recommend is accepting the relationship and then pressing Show Sick next to the constraint tool. This is going to reveal all of the constraints in your assembly that are impossible for Inventor to do, like all the problematic constraints, right? Here we can see that the problem is the stupid constraint that we told Inventor to make, which is obviously impossible. If we press delete on that, we can see now that things kind of go back to normal. And you can always check if you have sick constraints in your assembly by checking this Show Sick button. If it is grayed out, then that means everything is fine because you have no sick constraints. If it is clickable, it means you have made a mistake somewhere and you should go back and fix it, or else your assembly can get really whacked up with like all sorts of weird moving glitch stuff that's just really frustrating and terrible. It's really important to take care of your sick constraints, nurse them back to health. We like healthy assemblies, as sometimes they really can just make your entire assembly behave super weird, just be a pain to work with. Before we move on from flush and mate constraints, I want to talk about offsets. So if you put a non-zero number into this little offset box, it's going to change the offset of the constraint. So if I put 10 millimeters, you can see that these two faces will not only be constrained to be against each other, but they're also going to be 10 millimeters apart. This is going to force this space between them. And only exactly that space. It's the same idea with the flush constraint that you can't move it when that part is constrained. If I set the offset to a negative 10 millimeters, you can see the same thing happens in opposite direction. You constrain parts to be inside each other, something that obviously won't work in real life. So you need to make sure you're being careful with your designs when you're designing your assemblies to avoid parts clipping inside each other, just so you know that your design is actually going to work. That's one of the big things you got to look for, is like, where do you have parts that clip into each other, because that can really bite you in the butt. Another constraint is the angle constraint. I only ever use the first solution, and this lets you set two faces at an angle to each other. So if I set it to 45 degrees, for example, you can obviously see that these two compartments become constrained at 45 degrees, these two faces, right? The tangent constraint, you can select a cylindrical face and a plane face, and the cylindrical face is going to become tangent to the flat face. The last constraint that I'm going to talk about is called the insert constraint. It is a great way that you can combine two mate constraints in one. So it will constrain two axes together, but also two planes. Here's how it works. Click the rim of a circle. It could be a hole like this, like a channel hole, or a screw head. Notice the arrow coming off of it. Think of this like the arrow coming off the face of the mate constraint. If we do the same thing to another hole, now we can see that we have the pivoting bars again. But this time you did it with only one constraint instead of two. So this is a little bit faster. So usually in CAD there are multiple ways to do something. It's just that this constraint in this case is a little bit faster. Especially when you're doing screws. If you're trying to put a bunch of bolts, CAD all your bolts in your robot, definitely you want to get on this insert constraint thing. So you only have to do half the constraint you'd have to do otherwise. So using all of these tools together, I have not come across any parts in Inventor that I could not constrain together. So the more experience you're going to get with CAD, the more you're going to develop your own problem solving to be able to constrain anything you want. Using all of these tools, you can really just make like an entire robot. Hopefully you found all these constraints pretty intuitive to use. If you just use off-the-shelf parts, you really could design an entire robot using just these techniques. So next episode, we're going to take a look at sketches. But before that, your homework for this episode, you actually have to work this time, I'm sorry. I'd recommend you practice with constraints. Get a grip on constraints before you move on. Using the library, you can throw anything into Inventor that you want and tinker with the different constraint tools that are available to you. So you can make some channel architecture. Tetrix Cat, like I said last episode, that's a good one. Make a drivetrain if you want to actually do applicable work. Anything you want. Start simple. Tetrix square frame, man, that's something, the more that you can do, the better. So I'm going to close out this video by showing some examples of me tinkering around with some assemblies. I'm just going to kind of go off script and tinker around and make some stuff. So if you want to see me just mess around doing some constraint things, you can watch the rest of this video. The last few minutes is just going to be me messing around. So otherwise, go practice on your own and then watch episode 4. So with that, here we go. Alright, hello, I'm back after outro. This is Nick in the future, I guess, compared to me in the recording. I'm going through editing all these videos, and now I'm gonna do some impromptu CAD for you for some extra practice examples. I'm gonna see if I can, I'm not gonna make anything useful. Definitely not. I'm just gonna make something that'll that'll be there. So one thing, actually, yeah, I just remembered now. One thing that I forgot to mention. This is kind of laggy, isn't it? Oh, hello, thank you. One thing that I forgot to mention in the video that I've watched now that I've recorded it all. I'm not gonna go back and add it in the video. I'm gonna add it right now. Is about grounding parts, which is kind of interesting. If we constrain two parts together, let's do that. Let's get a flush going. So this is the sliding thing again. I can move both of these kind of together, and you might have seen me click this. There's a grounded tool, and now basically what happens is this piece won't move no matter what, which makes the sliding animation thing a lot easier to show. And if I make another constraint, and I hole punch these holes together, let's see here. Oops, that's right. That works, okay. This one can't move at all, and this one's grounded, so it can't move. And if I unground this part, now you see they both move. How about that? So grounding a part is really good for working in assembly. It's not. I can't believe I forgot to mention that. Definitely, you want to ground a central part of your robot chassis. So, like your drive frame, for example, like a part that you know isn't going to move that you want to sort of build off of. That's a pretty good part to ground. So, often like a channel that is on your drive train, or maybe like your structural frame. Those are good stuff to ground for sure. So let's see, what do we want to make? Let's slap some other stuff on here. What else we got? So our mounts in. You see, I made this. You think I would know? You think I would know where some would be? Here we go. Clamping mount. That's what I want to do. The big secret with CAD, as I will mention again later in the introduction video, is that nobody really knows what they're doing at any given moment. We're all just kind of figuring it out as we go, and it's it's off season, man. I haven't done that much CAD. I mean, like outside of this series now, it's kind of me just getting back into it. So we're gonna, well, yeah, what I'm doing now is I'm just basically attaching this. I've got the faces constrained and the two axes. Now this mount's on there. Let's go. I'm gonna ground that. So here's a common one that's a little bit tricky, is clamping mounts. This is a good one to do. I'm gonna constrain the I'm gonna try to constrain the axes. Let's see. There we go. That way, yeah. So we've got this constrained now. Oh, this is a yellow jacket, not a spur. Okay, well, we'll make it work. So get a flush. Offset this. Because when you're clamping a motor, you don't often clamp it, right on the front. You do it on the gearbox somewhere. So you can offset this. Let's see. Let's go 20 millimeters. Sounds right. Negative 20 millimeters. There we go. Perfect. So now this is kind of on here, but you see it's still all rotating because it's not fully constrained within the clamp mount. And so you might think like, okay, well, how am I going to constrain this on this rotational surface? And for this, again, it doesn't really matter because it's a orbital motor. Let's say this was a spur motor, then the center point of your output shaft would be rotating around the center point of the clamping hub. So then it's pretty important to have your motor anchored in a certain position. And what I like to do, what I came up with doing, is if you find a flat piece of geometry like this, and you can use the angle constraint. This is one of the only times that I use this, by the way. I don't use it very often. You can set this face to be 0 degrees, and now it's not going to rotate anymore. Because there has to be 0 degrees between these two faces, so it can't rotate. So if you can find two planes that you want to make parallel, that's what I mostly use the the angle constraint for, is you can make two faces either parallel or perpendicular, and that becomes very handy with motors and sometimes with servos too. Let's try to do a servo. Servos can be pretty bad as well. I'm trying to do all the bad stuff, so you might have an idea for side of our channel. I want to do it off the side, so let's see here. These even these sort of ovular elliptical cutouts, they still have axes you can constrain. This one's got two. You can do one here and one here. And you want to be really mindful of that when you're doing a constraint like this. That gets pretty important. Make sure you select the right one. I often just turn it and line it up. Let's see, so some of these don't line up at all. What is that? I think we probably can do this though. Yeah, that works, nice. Cool, cool. All right, that's done. These to constrain, gonna do it like that. Nice, that works. Now I know with the rev servos for at least, these two planes are like on an angle, like these two faces here, here and here. So I'm not sure if this is actually parallel or not. I guess I can't select that anymore. I don't know. Let's see. Let's see. Oops. If this will give me what I want. Oh, nice. So I guess Go Build This servos actually have flat plates like that. Let's try to put let's just do a rev one. Yeah, these things. Man, all the rev plastic stuff. Yeah, because look at this. You see this? Stuff kills me, man. This slight arc. It's like a circle, like an inscribed arc across the bottom feature. The Go Builder ones are flat. This one's not. Okay, let's do this. This is not going to fit very well at all, I don't think. At least the hole sizes are going to be different. Although, maybe it'll work. I don't know. Oh man, you gotta love metric spacings. If you're doing Robotics, man, you're doing something wrong. I love the I love Go Build more than Robotics just for build systems because you can interface it with rev parts or Tetrix parts so much easier. And being able to do something like this, just you can just use a rev servo bracket on a Go Builder channel is just like so convenient if you have that stuff laying around. So like buying into like Imperial parts. What else is Imperial? I think Bex. I don't know who uses Bex CDR anyway, but yeah, this is it, man. You want to use rev. All right, let's do this. Oh yeah, by the way, I didn't mention this either. This solution thing, I think it was new in Inventor 2019. I upgraded from 2018, so it took me a minute to figure out how to use this. You can change your solution with your axis constraint, your alignment. And if you do this one, if you ever get an error doing one of them, you can always just go to this third one, which is undirected, and basically it's sort of how it used to be in Inventor. So if you're upgrading from an old version of Inventor, you click on this third solution here, if that's the one that you're used to using, it basically means that it doesn't matter which orientation your servo is, so this could be upside down and it wouldn't give me an error still. So if you're getting an error doing a solution, just hit the third one, forget about it. It doesn't really matter. So let's see here. Okay, so now I've got this thing constrained, but I think this should give me an error. Try and do that. Yeah, it doesn't like it because this thing's on a curve and it's annoying, but this is what you do. This is really helpful actually as well. So you got this face and this face is flat, right? You want to get the edge because this is just a line, and so a line can intersect a plane just to a point. So now it's kind of hard to see. This part of the thing is almost like a little triangle here, down to this corner and then up. This point is touching the ground of this bracket, and this part's up in the air just a little bit because of the curve. So that's something that's really helpful to do too. So you can select points when you're doing constraints, points and lines, and that can be very, very helpful with dealing with stupid geometry like the rev servos. So what else I'll do? I'll do a wheel, just because I don't think I've shown a wheel yet. I'll put a wheel on one of these motors. Another pro tip, don't use set screws, because those are they're just really bad. Yeah, you don't want to do that. You want to use a clamp and hub, that's where it's at. Axis constraint instead. So, of course, in real life, you wouldn't have the D part of this clamp clipping through the axle. You know, you see how it's going straight through metal. So, in real life, you wouldn't have to do this. I'm sorry, you wouldn't build this because it obviously wouldn't work. But for CAD purposes, since this motor is perfectly anchored down, and you can't actually, as far as I know, unless you split it into two different, it would get really complicated. You're not gonna animate your motor axle spinning, so animating a color or something on your axle, your motor output shaft, or like a wheel, rather than constraining it all exactly, is probably the move to do. Because you can build this in real life no trouble. There's a few things that are like that as well. Sprockets, for example. CADing chain in Inventor that works, I think, is like next to impossible. I don't think I've seen anyone ever do that. In SolidWorks, it's a bit easier to do, but it's still really, really advanced. CADing like the chain links and they all move together. What you should do is just put the sprockets and just leave the sprockets empty. Same thing with like a belt as well. Belt's a little bit easier because if you want to test your sizing, you can like make an outline of it. But actually like animating it, like that's more like CAE stuff, like computer aided engineering. And that's like really advanced stuff that you can do with CAD. Like I think there's like only a handful of teams that do that for FTC. Some of them do for FRC, but yeah. So if you ever get into a situation like that, where you know that you can practically represent something in CAD, by like leaving it a little bit unfinished, but it will still work in real life. As long as it works in real life and you're very confident about that, it's okay to do that in CAD. That's the note there. So let's see. Yeah, I did. Cool. There you go. So now we can spin our wheel. The hub it's on is spinning as well. You could build this. I don't know why you build this, but you could. So that's a little bit of harder stuff to do with the wheels and the servos and such. The thing about extrusion that I mentioned in the main video, which is really important, is that there's no holes except for the very end. You've got one tiny little hole, and I guess you have each of these four corners. So it's very hard to constrain with like axes constraints, because you don't have very many axes to constrain to. Perfect, just what I'm looking for. Love these things. Can't tell you how many times I've done this exact thing I'm about to do. Just if I want to, I'm making I should have clarified this. See there, I'm making a corner out of these 2 rev extrusion. Boom. Done. Right. So now I've got these 2 guys just kind of floating around. So we gotta do some flush constraint magic here, where we can select the edge of this bracket and the edge of the extrusion. And when you work with CAD, you sort of have to pay attention to geometry that you usually kind of ignore. Like, who thinks about this part of the motor, you know? But it's part of the part file, you know? And if it's part of the part file, then you can use it for anything like that. So sometimes with like sensors and stuff, I think it's really confusing because some of them have curvy plastic geometry. You can even get into like the electronics pins, and like because there's right angles here, and there's planes that you can use to constrain to other stuff. And so yeah, using the sides of these brackets, for example, these little edges, is super good, super valuable, because otherwise you'd have a hard time making this stuff. This corner is going to go onto the edge there. So now you could take your T hex screws, right, and feed them along the extrusion, and they'd come up through this bracket, and then you could put your M3 nuts on the other side. This is all perfectly constrained. Now you've got a little right angle, and I've made many corners like this before. So that's a little bit of extrusion work as well, which is something like that. And a lot of the whole assembly stuff is just going to be on your problem solving, which is why I said in the video, I guess it was the introduction video, that's really the most important thing is understanding your tools and being able to apply them to new situations, because this is just like a little sample of things that you might CAD at some point, you know. Like doing the servos can be a little tricky, extrusion can be a little tricky, D-shaft can be a little tricky if you don't think about it. So you really just have to look for geometry where you can find it and take advantage of everything that you have. And just remember, there's no, well, I guess there are some pretty wrong ways to do stuff, but there's a lot of ways to reach the same effect or solution. Like I'm sure there are other ways of doing this intersection. Some of them might be faster. But, all of this I basically did with just mate constraint for face and axes, and then angle for this motor, and that was it. So it's 3 constraints, and I built all this. And so I just kind of wanted to really prove to you that I could, make more than just channel with a few simple tools. And really, you can. Like, you can do so much more impressive stuff than this. And honestly, like, if you're using Tetrix or you're using an Actibotics kit of parts or a GoBuild kit of parts, you can really just make your whole robot using just this assembly skill and the assembly features. I would highly encourage you, if you're doing CAD, to start doing custom parts if you can. So if you can do like CNC machining, that sort of thing, I think that's really good to do. But that's for next episode. Oh, hey, what do you mean that was just a segue into next episode? That wasn't a tangent. It's just a segue, because next episode is part making, right? Part making part 1. So we're going to talk about making custom parts, which are pretty sweet. So check that out. Brush up on your constraint stuff if you are trying to follow along. That can be good to do. So thanks for watching. I will see you in the next episode.